All right, this video is going to break down two very important parts to the properties of exponents. How do negative exponents work and how do fractional exponents work? We're going to start with negative exponents. Oftentimes when I introduce kids to negative exponents, they assume that the results are going to be negative, and that is not the case. Actually, what ends up happening, think about if you have a positive exponent, the number usually gets significantly larger, significantly bigger, because you're multiplying it by itself so many times. However, when we're dealing with a negative exponent, what you're going to see here is x to the power of negative 2. You just take that x to the power of 2 now, it's a positive. After you move it down to the bottom of a fraction, it becomes your denominator. Okay, now say x to the negative third power. We're just going to put x to the positive third power down as the denominator, and up on top just goes a 1. We're just making a fraction. We're essentially making this number very, very, very small. Okay, x to the power of negative 4, again, we're just put 1 on top, x to the power of 4 on bottom. So now that you see the rule and how a negative exponent works, let's actually throw a value down as the base, and let's see what happens to 2. We're going to make 2 significantly smaller, okay, but we're not turning it into a negative value. We're just making it a very, very small number. So 2 to the second power would go on bottom, 2 to the second power with a 1 on top. 2 to the negative third power means take that information, put it down on the bottom with a 1 on top. And 2 to the negative fourth power says put that information on the bottom. Again, now it's a positive exponent with a 1 on top. So if you look at these rules here, we've just followed these step by step. And now we can simplify the bottom of each fraction. Okay, so we're going to simplify 1 over 2 to the second power. Well, 2 to the second power is 4, so it's really just 1/4. We made 2 into 1/4. We made it significantly smaller. Okay, 2 to the negative third power, 2 to the third power goes on the bottom. 1 over 2 to the third would become 1 over 2 times 2 times 2, which is 8. Now we have 1/8, even smaller than 1/4. If we go to 2 to the negative fourth, we're going to get even smaller than 1/8. 2 to the negative fourth power becomes 1 over 2 to the fourth power, and 2 times 2 times 2 times 2, 4 times, gives me a 16. So we go from 1/4 to 1/8 to 1/16. The smaller these negative numbers go, the smaller our value will be at the end. Okay, so keep that in mind. Hopefully you took some notes on this. We're going to go and break this down with some examples now. All right, now let's learn what we used with some very low-level basic problems that involve negative exponents. I got 2 examples for you here. I'm going to break each one of them down, and you should have a better understanding of negative exponents after this. Okay, common mistake that I see with a problem like this, 3x to the negative fourth power. A lot of times kids will assume the negative 4 exponent is attached to both the x and the 3. However, the coefficient of 3 has its own exponent right here. There's nothing showing, so we need to know that there's actually a 1 there. And 1's a positive exponent, so that's not going to change that at all. It's actually going to remain on the top of the fraction. And keep in mind, remember, when we have a negative exponent, we need to move that down to the denominator and turn the negative exponent into a positive. So all you would need to do in a case like this is if you don't see an exponent up there, it's always wise to put a 1 there so you remember it's there. So 3 to the power of positive 1 doesn't change at all, stays right there. But x to the negative fourth power, remember we need to push that down to the bottom of a fraction, so we need to draw a fraction bar. And x to the negative fourth just becomes x to the positive fourth, but now that it's in the denominator section. Simplifying 3x to the negative fourth power would give you this result here. Hopefully that makes sense. Now we need to go over to a problem like this, which is slightly different. If you look, we've got parentheses around the entire term. That means that that negative 2 is going to go to both parts, the 6 and to the 3, and we need to use the power over a power rule. So if you remember from earlier lessons, that negative 2 needs to be multiplied by the 6 and multiplied by the 3. So after we do that, we're going to end up getting 2. 3 times negative 2 gives me negative 6. And x to the 6th power, 6 times negative 2, which is going to give me a negative 12. Now both of my exponents are negative, so they're both going to have to move down into the denominator section of a fraction. So let me just draw a little arrow here going down. We're going to draw a fraction bar. We've got nothing on top. Remember, if we have nothing on top, we just put a 1. Okay? X to the negative 12th power becomes x to the positive 12th power, but down in the denominator. And 2 to the negative 6 becomes 2 to the positive 6th down on the bottom of the fraction. Okay, if you're looking at this, we can go a couple of steps further. We can take 2 to the 6th power and we can turn that into its own value. So 2 times 2 times 2, 6 times. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is going to give me that 64. So my final result here is going to be 1 over 64x to the 12th power. And that is how you would simplify expressions written with a negative exponent. All right, now let's talk about fractional exponents. What is a fractional exponent going to do? I'm going to use a little bit of algebra to help you understand the rule. Then I'll give you a couple of easy low-level questions to start practicing them. X to the power of m over n. All you need to do in this case is take the denominator of the fraction, that n in this case, is going to go right here. So we're talking the nth root of x. The base goes right underneath the radical. X to the power of m. So anytime you have a fractional exponent, your numerator is going to go inside of the square root symbol, the radical, with the base, and then the denominator goes outside of the radical, so the nth root. For example, if I were to say x to the 1/3 power, that's just going to be the cube root of x. No need to put the 1 right here because x to the power of 1 is just x anyways, so there's no sense in even putting it in there. Okay? So if we think about what is x to the 1/2 power going to be, it's really just the square root of x. And remember, when we're talking square root, there's no need to even show the 2 there. We just show the symbol. Okay? So 1/3 would be the cube root, 1/2 would be the square root, and then m over n is the nth root of x to the power of m. Okay, let me give you a couple of examples. We'll go over this and you should be ready for your upcoming test. All right, I got a couple of examples for us to work out here, each with a fractional exponent in them. So the first two just have a 1 on top, which makes it a little bit simpler. And then I gave you 4/3 over here so we can break down what to do in that scenario. We got our rule right over here that we just talked about, so let's use that to help guide us through each one of these. So if I'm going to go and simplify 25 to the 1/2 power, first thing I need to do is take that denominator 2. That's going to tell me what root I'm taking. I'm taking a square root. So no need to put a 2 there. We're just taking the square root of 25. And I could take this 1 and put it right up there, but 25 to the power of 1 is just 25 anyway, so there's no sense in even doing that. So we'll just remove it. And if you look at 25 to the 1/2 power, it's basically saying what's the square root of 25, which we should all know is 5. And that is how you would simplify this term right here. 64 to the 1/3 power. Now we're not taking the square root. Now we're going to be taking the cube root of this. So if I'm going to take 64 to the 1/3 power, that is the cube root. Remember, the bottom part of the fraction goes outside. That's the root we're taking. So we're taking the cube root of 64. Again, my top number, my numerator, was a 1. No sense in putting a 1 down. We just got to determine what's the cube root of 64, which basically means what number times itself 3 times gives me 64, and we should know the cube root of 64 is 4. Why is it? Because 4 times 4 times 4 makes a 16, times another 4 makes a, times another 4 is going to give me that 64 that I'm looking for. So what would your answer here be? It's just going to break down to 4. Now we go to this last and final one, which we have a numerator that's not 1. So it changes things up a little bit, right? We can't just take the cube root or the square root of something. In this case, we're taking the cube root. So we're going to go cube root, 3 goes there. 27 comes down and goes right inside. And then the 4 needs to go up above the 27. So which order do we do this in? We need to take the cube root of 27 first. So what number times itself 3 times makes 27? What number times itself 3 times makes 27? That would be 3 times 3 times 3. 3 times 3 makes 9. 9 times 3 makes 27. So what I know is the cube root of 27 is 3. But I now need to finish this problem by bringing that 4 down as an exponent and then figuring out what 3 to the 4th power is. Now 3 to the 4th power just means 3 times 3 times 3 times 3, 4 times. So if we want to write it out, 3 times 3 times 3 times 3. If you know your trick, you can multiply those two together and make 9 and 9. Then multiply the 9s together to get 81. So our final result here would be 81. Okay, hopefully this is making a little bit of sense. Fractional exponents can be a little bit tricky, but the more and more you practice them, the more and more you're going to get the hang of it, writing them down and then simplifying them out. I'll make another video tomorrow with some more complex scenarios, break those down, show you step by step how to complete them. Study hard and good luck on your upcoming test.